Okay, good. So good afternoon, everybody. And my name is Edin Omrdic, and I'm a senior research fellow at Center for Robotics and Intelligence Systems at University of Limerick in Ireland. And welcome to the EMRA 2021 afternoon session. I'll be chair of this session. And in the next 1 hour, we will have 4 presentations, and there will be a mix of EU-funded projects, but also we will have also industrial project presentation. And just to inform some of you maybe who could not see the conversation in the chat, if you want to raise your hand, please go to the bottom of your screen. You have a reactions icon and select from that reaction icon raise hand. Okay, so the first speaker now is Mateo Ivanac from the Croatian Chamber of Economy, Croatia, and the title of his presentation is INNOVAMARE, and dive into the depth of the opportunities. And please, Mateo, the floor is yours.
Thank you, Mr. Omrdic. I hope you hear me all. I will share the screen with you with the presentation of the project. Just a second. Okay. Do you see it?
Yeah.
Okay, great. So thank you very much for this opportunity to present you all of the project that we are working on for almost a year now, but we were developing it for a year and a half. So basically now we can say that 2.5 years we are working on the INNOVAMARE project. So basically, when we started to think about the project, we wanted to see, as this is a program of Interreg Croatia-Italy, what is the biggest natural ecosystem that has a huge effect on economy in Croatia and Italy, and how we can, through technology, affect this ecosystem and make it more sustainable. And we came to Adriatic-Sea as the most important ecosystem, natural ecosystem in Croatia and Italy, that is really having problem with sustainability and with pollution of Adriatic-Sea from different sources. So we came to analysis of some of the pollutions and that are the problems and challenges of that. So 49% of the known forms of life in the Mediterranean are present in the Adriatic Sea. By 2050, sea level is expected to rise for 12%. 64 known fish species are threatened with extinction, largely because of overfishing. We have amount of marine litter 2 to 5 times greater from those in other seas. And we have solid waste and direct discharge of wastewater are key negative factors for degradation of coastal and marine ecosystems. So basically, we wanted to see who is affecting these problems, these challenges, and in which way, and where to look for the solution. Besides that, we have to say what are the 4 most important sectors in Croatia and Italy that has effect on this pollution of the Adriatic Sea. So this is the agriculture, fishery, sea traffic, and tourism. Only in Croatia, there is 170,000 people employed in these 4 sectors, and even more than 5 million people in Italy. So we came to the conclusion we need to build innovation ecosystem that has a purpose on developing innovative solutions that could tackle this challenge of monitoring and prevention of sea pollution. We wrote the project and we got 5.6 million euros as a strategic project in Interreg Croatia-Italy program. There are 4 universities, 3 maritime institutions, 3 business supporting institutions, 1 maritime cluster, 1 regional authority, and 2 companies, SMEs. You'll see from Croatian and Italian side which are the partners. So from Italian side, there is a cluster, one of the big clusters in Italy, MARE FYG, University of Trieste, Union Camere del Veneto, it's a regional chamber of commerce of Venice, National Institute of Oceanography and Experimental Geophysics, innovation agency from Bologna, a regional agency for technology and innovation from Puglia Bari, and Institute of Marine Science as well. From Croatian side, we have Croatian Chamber of Economy as a lead partner, Institute Ruđer Bošković, Faculty of Electric Engineering and Computers, University of Rijeka Technology Transfer Office, University of Dubrovnik, Šibensko-kninska County, and the company Geomar DO. What is the main aim of Project INNOVAMARE? We are trying to develop and establish cross-border innovation ecosystem model in area of underwater robotics and sensors for purposes of monitoring and prevention of sea pollution with a mission oriented on sustainability of Adriatic Sea. So basically, when we defined that we have a huge problem with pollution of the Adriatic Sea, we wanted to see what technology can be most used in developing new innovative solutions that can tackle this challenge and bring new innovative solutions in monitoring and prevention of sea pollution. And we saw our focus in technology of robotics and sensors. And this is why we are focusing on these two technologies. How are we going to develop innovation ecosystem in underwater robotics and sensors? By raising of collaboration of innovation players and giving them mechanisms and tools for boosting development of new innovative solutions in area of underwater robotics and sensors. We have four main outputs of the project. Establishing digital innovation hub for innovative underwater robotics and sensors on cross-border level. It will be placed in Croatia and in Italy, and it will look on a cross-border level to help companies and scientific research institutions to cooperate, collaborate, and develop new innovative solutions that could help local government, local and regional government, and other institutions in tackling challenge of monitoring and sea pollution. We will develop strategy and action plan for model of innovation ecosystem. So the process of developing innovation ecosystem could be used for other areas, not only in part of robotics and sensors, but in other areas for anyone who are trying to develop innovation ecosystem. We will, through project, create a prototype of innovative robotic and sensor solution that will be a showcase of cooperation between science and private sector to show what can be done with these technologies in monitoring and prevention of sea pollution. And at the end, the most important part of the innovation ecosystem and the digital central place is a web interactive platform for collaboration. We will develop in this interactive platform a so-called map of excellence, where we will try to gather all the projects or the innovation players from science, private sector, and local and regional government. So at one place, we have the overview on a cross-border supply chain in robotics and sensors that are dealing with sea or sea pollution. So what is our vision? Our vision is to develop cross-border innovation ecosystem in Šibenik as a leading center of cooperation and knowledge and technology transfer for development of new innovative solutions in underwater robotics and sensors. It will be a central base in Šibenik in Croatia, but it will be as well represented in Italy as well, and will be really collaborating on cross-border level. But we have a clear mission, and it is to pave the way on cross-border and transnational level of collaboration and knowledge transfer. For one mission, it is the sustainability of Adriatic Sea. So the concept of innovation ecosystem has begun to attract attention as a framework for policymakers only in recent years. Innovation ecosystem is term used to describe the large number and diverse nature of participants and resources that are necessary for innovation. So basically, this is our aim to gather all the stakeholders in innovation ecosystem that could help us to develop a community of solution providers, but on the other hand, those who are needing the help of technology as robotics and sensors in problems of sea pollution. How does INNOVAMARE innovation ecosystem looks like? It will gather in its core four main pillars. Pillars from scientific research institutions, civil society, business, local and regional government, but really important are together media, financial institutions, venture capital funds, private equity funds, and public institutions who will help to bring this innovation ecosystem financing, media coverage, and possibility to affect with its stakeholders to public institutions for changing some recommendations that are needed for better implementation of technological solutions from robotics and sensors. Why innovation ecosystem? Well, when you have a small number of diverse stakeholders, then their interaction and the information flowing between them is really easy. As you bring new stakeholders and the number of stakeholders is rising, you need to have some kind of a facilitator that could bring the innovation and the resource in the right time at the right place to those stakeholders that it needs. So the innovation ecosystem is the way how to have the overview of all the stakeholders, and at the same time to that stakeholder bring the innovation, information and resources at the time they need it and in the place they need it. And this is where we see INNOVAMARE as a really important factor. Inside of innovation ecosystem, it will be developed a digital innovation hub called MAIROS, Maritime Innovative Robotics and Sensors, and it will consist of four pillars services. It will give education to companies, scientific research institutions in fields that are necessary for raising their capacities as digitalization, new business models, technology transfer, knowledge transfer. And this is the pillar that we see as a really important in a way that helps all the stakeholders coming on the same level of competencies. So in a way that can bring their collaboration even faster between them. Regarding the collaboration, we will develop web interactive platform, and in collaboration, we are trying to combine those who need innovative solutions and those who are giving the innovative solutions in a way through map of excellence, where we'll have the overview really on each case scenario, on each stakeholder, what their innovative solutions are. And at the same time, we'll have the input on who is needing this innovative solution. As a digital innovation hub, then we will help as a facilitator to bring those stakeholders to collaborate. Regarding the technology transfer, our aim is to have a better knowledge transfer and technology transfer from universities to private sector in a way that we will have the technology agents who will help the experts for scientific research institutions to spread their knowledge and expertise to private sector, to companies that they need the most. The fourth pillar is idea tunnel financing. As I said before on the picture, by bringing venture capitalists and financial institutions inside of innovation ecosystem, we will have so-called innovation hub, where we will ask for the small and medium companies for the best ideas on solutions for monitoring and prevention of the sea pollution, and in the same time bring these ideas to the and present them to venture capital funds as well as financing institutions for possible financing of this idea, and in that way, as a facilitator, help them to bring this solution to the market. In total, we will have 104 activities in INNOVAMARE project, and we will gather around 1,000 stakeholders on a cross-border level through the innovation web interactive platform. And you see all the stakeholders that we are trying to attract, not only the companies and universities, but as well as NGOs, local and regional governments, local and regional authorities, center of excellence, etc. Please, I invite you to, at the end of this year, to join us on our journey on Web Interactive Place that we will develop in this project, and to work all together in one mission, sustainability of Adriatic Sea. Thank you.
Thank you, Mateo, for excellent presentation. And since we started this session with 10 minutes delay, I would propose the following schedule. We will have all four presentations in a row without interruption, and we will collect all the questions. And then after the all presentations are finished, we will ask each individual presenter to answer the questions, and then after that we will have a discussion. So I will just now move to the next presenter. That's Jorge Diaz from University of Porto, Portugal, who will give the presentation about research innovation program ECOBOTICS.SEA.
Good afternoon to all. First, let me tell that I'm quite happy to join this community. I'm a little new on this community, and I hope that you know that I can just left a small contribution, very small, in fact, with this project that I have. First of all, I would like to ask you: are you seeing my screen totally, or double slides? I don't know when I see it. Right?
We don't see your screen, but please, if you share your screen, it will be the best if you start your presentation first and you share the screen where the presentation is displayed. You know, so that's the best way to know.
You mean is this way is better? No.
Not yet. We don't see your screen.
Oh yes, I'm sorry. I need to share it, right? Oh, of course. Of course, I need to share it.
The presentation.
Yeah, yes. Of course, I need to share it. Okay, so let me see if it's okay now.
Okay. The point is this: we see your presenter view. Okay, now it's good. Great.
Now it's good. Okay, great. So yeah, so my colleague, we initiated this project ECOBOTICS.SEA some time ago, but unfortunately, let me tell you, this project is a Marie Curie project, and the Marie Curie projects, some of them, like this one that is RISE, is based on mainly on the exchange of researchers. So this pandemic is not really as useful for us in this moment, because in fact we almost stalled this project, you know, since 1 year and some months. Okay, let me tell you that. But anyway, I would like to present what are the objectives of this project, and also the kind of work we are just doing now, and also what we intend to do in the very near future. Okay, so basically the project is research training, and research by training, it means that we accept students and the PhD students and researchers to come together, and the main idea is to use robotics as a tool, as a device that can make observations and monitoring marine species communities on focusing mainly on modeling the aquatic biodiversity that you have, and help to have, let's say, better understanding about ecosystems, mainly on the water. So that's the idea of this ECOBOTICS. ECOBOTICS.SEA means that is ecobotics on the sea, and they have also another trend to look at on the land and also in the air, right? So this is the other aspects of this ECOBOTICS. So basically, the ECOBOTICS is supported by interdisciplinary research. We pick up this knowledge by different partners, and partners that have knowledge on basically using intelligence and hardware, or let's say embedded intelligence in the hardware, like biomimetic artifacts, to can be a support to make the observations on the ocean, on the water, or some ecosystems. The idea is doing that with exchange of partners and researchers between places, students included, and maybe open new business opportunities for companies that we have also in the consortium. So this is the consortium. We have my own place that I came, University of Coimbra Institute of Systems and Robotics. We have Tallinn, that is another university. We have Technical Lisbon, Phobos, Evologics, and 3 divisions, all them people coming from Europe, and an external partner coming from India that they call it NEO. That is an opportunity for us to also testing our devices far away for this institute that is looking for aspects of the water. So basically, the profile of the partners are mainly, as you can see, academic partners that interact with companies, and this interaction we intend to leverage innovation and leverage also some research challenges that we know that these people that from Evologic, Phobos, and 3 divisions have. So basically, the team on ISR are mainly dedicated with artificial perception part. We do all the kind of, analysis of imaging and also control based on imaging, some computational intelligence control parts, and the field robotics part. And we have Tallinn that is a little more oriented for using devices and construct devices with bio-inspired, with mainly big interest on new materials or new embedded intelligence on the materials, like artificial muscles or flow sensing, or some kind of capturing parameters from the fluids, like fluid dynamics to when we have in the ocean, and they have a long history on these studies. And Pascual, that is a person that already talked this afternoon, and also be a share in one of the sessions. That is our colleague Antonio Pascual, and all this team where have a long history on unmanned vehicles that for exploration. NEO is mainly an extension of the research that we do. Is Oceanographic Research Institute in India, and this is kind of inclusion of these new countries for supporting, analysis of ecosystems in India. And Evologic is a company that is well known in the media, and they have, very interesting devices like this mantle ray that everybody knows, and do beautiful videos about this mantle ray, but also sensors for, solutions for communications underwater, and also for surveillance of waters. Phobos is a different company, more related with surveillance based on the air. They have solutions that are with vehicles that are flying, but interacting with also marine devices. And it is, they are mainly dedicated to using water analysis, and this is why they have them. And 3 divisions, that is mainly the broker for innovation, that is catalyze the knowledge of different partners and trying to do consulting to put this in a project that later on generate spin-offs. So this group, we have, launched this long time ago in January 19, but, we have a first presentation in EMRA in 19, and along the time, we did some work, but as I mentioned to you, after this pandemic, we just have a big stall on our project. Basically, the activities that we do on the project are quite different. Some of them dedicated to, profiling the underwater wildlife, and looking for technology that supports technologies that support this profiling. how the population behaves, how some of these species behaves, and we are mainly interested on fishes or big fishes, or that we can see some kind of behavior that sometimes are really interesting, like have some social interactions sometimes. And this is, we are looking for this particular science oriented aspects on the analysis of this of the systems, of the ecosystems. And we are also have one project under this big umbrella of ECOBOTICS.SEA that are mainly dedicated to analytic models for movements and patterns of movements of vehicles that are navigating under the water, and see how they can be more adaptive to live and be accepted by another animals. And this is an aspect that we are also pursuing on this Marie Curie project. And we have projects are dedicated just to the locomotion control, bio-inspired, mainly based on looking for how the fishes operate and how the fishes move. Sensing control also in the same way. And have a special dedication for hardware and computing architectures that we can use internally to these devices that make it them energy efficient, and also not just that, using some kind of computing that allow you to explore new frontiers on computing, like probabilistic computing, or dedicating stochastic machines that we can use for dealing with a lot of uncertainty that we have on the data. We have also two another projects more related with previous technologies that are looking for multi underwater tracking systems, and also how they can communicate this multi underwater robots using acoustic and optical communication networks. On the energy efficient bio-inspired hardware, we have done some interesting work. Mainly is pushing from what we call it edge computing to be more adapted to on the systems that are operating under the water. We use a different way of doing the computation. We use what we call it Bayesian probabilistic machines or computing that use bit streams, stochastic bit streams, to massively do the computations and compute the inferences and the predictions efficiently. And this is a spin-off from a previous project that we have done on the call it Bambi, that is related machines that are specifically dedicated to Bayesian inference. That is a previous project that gave inspiration to this part of the project. And since this computation has become a little more simple than the ordinary embedded system that you have, normally they can be used for consuming less energy and to have good let's say performance. And the performance that we are looking for is the energy and time on the precision of the data that you got. And this is, we have studies done for both localization or target localization. This is some of the results that we have done, and in computing and looking for the experiments doing this computation. We have different let's say publications until we put the project on hold. This is some of the publications we have, and this is what we intend to do in the future. So another aspect that we initiated and very successful is bio-inspired underwater locomotion and control. This is coming mainly by Tallinn, where they develop a device that we can control this way of controlling the robot that they call it UCAT, sorry. and that is one way of making the locomotion of these devices a little more, based on fins, and how these fins can be used to be controlled to generate some kind of trajectories on the space using the specific control for a device like this one. Okay, so this is a picture of the device, and yeah, this is one of the results. Some of the experiments on this issue is this interesting application that our colleagues from Tallinn have done with using this someone like smaller control robots to looking for how the animals are operating in natural environments on the aquaculture, and they have also did some interesting spin-offs on their work that is are in this publication that you can see. Sensing control is another area. This is actually the ongoing project. They develop sensors for sensing the flow of the water, and this is really important aspect that everybody that works underwater knows that is extremely important to see the flow on rivers, on dams, and other situations to characterize the environment itself. And they have also did some studies initially under this umbrella of this project. And this is one of the publications they have done. The impact of COVID, it was really hard for us. And actually this project is currently on hold since May last year, because CIS operates on the exchange and secondments between people. And actually it will try to reignite again the exchanges activities for September 2021. And this is also an opportunity to all the people that is attending this workshop. If you would like to apply to this project, please contact this project and myself, and I will be happy to integrate you on these activities on the ECOBOTICS. The next steps that we are dealing currently, we are mainly doing, and the next steps means next activities that we just trying to put on place in September is monitoring of marine species, focusing mainly on biodiversity using image data and video analysis using techniques like the techniques of artificial intelligence that everybody was talking about and very recently. Another aspect that we are expanding much more, and maybe looking for partners for possible joining the group for possible proposal from this H2020 is exploring this edge computing scheme using our techniques for computing, and that we always also intends to be extended for communication using optical acoustic and hybrid optical acoustic communication on underwater harvesting of data, something related with the data acquisition that some of you already mentioned. So this is in the very brief minutes what is about this project, and that's what I would like to say about ECOBOTICS right now, that will start soon again, the activities that are available for the community for looking for the analysis of the ecosystems under the water. So this is my talk for now, Edin. So please.
Thank you, Jorge. It was an excellent presentation, but as I said, we have some time constraint. We already some questions for you, but we'll leave it after all sessions, after all presentations are finished. So we are going now to move to next talk. Next talk will be given by Massimo Caccia, my good friend and colleague from CNR-INM, Italy, and he will talk about MATRAC-ACP project and real-time adaptive monitoring for coastal port areas. Caccia, please.
Okay, so now I should be unmuted. Thank you very much, Dino. And now let's go to share the screen. And okay, now you should see the presentation, I hope. And good morning, good evening, everybody. And today I'm here to tell you something about this MATRAC-ACP project that I'm coordinating. And the project is about adaptive real-time monitoring with automatic sampling and measurements of harbor waters. And the project MATRAC is funded by, in the framework of the Maritime Italy-France program, that is a interreg program that involve 2 regions in France, Corse and PACA, and 3 regions in Italy, Liguria, Sardinia and Toscana. And this conference, PISA, is inside this interreg Maritime Italy-France region. And this area is characterized by very important harbors. We have, for instance, Toulon on the French side and Genova in Italy. And that were for many times in the history a door to and from the world. But what happened during last century, especially during the second half of the 20th century, was that the harbors got and were perceived by people as a kind of a separation between the city and the sea. And what we started to do in the last 30 years, for instance, in Genova from 1992, was to try to make again the harbor as a part of the city, make it accessible to people and so on. But for doing that, you need a good quality of the waters inside the harbor. So you need to monitor the waters, you need to make actions to improve their quality and so on. And in this region, we have also a tradition of research in marine robotics and technology. So for instance, we have the Pôle Mer Méditerranée and EMRA on the French side. We have our Institute of Marine Engineering in Genova of CNR, a very important group in University of Genova and ISME, the Ligurian District of Marine Technology. And so there is a core of technology related to marine robotics in this area. So the idea of the project was to understand and to see how robotics can help to improve the monitoring of the water quality, and also how this kind of real problems can motivate and force the development of new technology, so that the harbor can get again a kind of engine for technological development. So, which are in this, with this idea in mind, the expected result of the MATRAC project are cross-border definition of innovative shared protocols and procedures for monitoring of marine waters in ports, because we have to remember that the monitoring of water quality inside the harbors is made on voluntaristic base by port authorities. There are not rules for doing that, obligations by rule. Implementation of a core software system in charge of real-time processing of sample data on the flight and driving the robotic platform according to an adaptive schema, and then the adaptation of state-of-the-art underwater robotic systems, autonomous or tethered, and development of automatic instrumentation for water and sediment sampling. So we had, for doing that, some very interesting research and development and innovation challenges, such as the definition of suitable procedures and code of practices to operate unmanned marine vehicles in civil environment during daily operations, the design and development of light and cheap communication and localization systems for underwater sampling in port waters, and the integration of geochemical sensor package on small, easy portable AUVs. And the sensor package is quite rich: methane, carbon dioxide, hydrogen, hydrogen sulfide, chlorophyll A, pH, conductivity, dissolved oxygen, turbidity, and many others. So, which is the main architecture of the system? We have, of course, a human-computer interface for the end user, and then a geochemical module that, on the basis of current measurements, understands where it is better to collect new samples. So the mission is planned, and also a view of what's going on, of how the reconstructed model of geochemical parameters in the water mass is evolving is shown to the user. And then, of course, it is connected to the sampling node that is the robot equipped with different sensors. And from the point of view of the adaptive sampling strategy, it has been developed together by mathematicians and geochemist researchers. So the idea, which is the idea of the adaptive approach, with selecting the next sample position on the fly based on the current estimation of what's going on. So we have real-time measurements from sensors, update of an estimation map at each new incoming sample on the basis of geostatistical techniques, and knowing what's going on from the geochemical point of view. Then we build an uncertainty map related to the estimation, and on the basis of that, the next sample position is selected in a maximum uncertainty area. And the map is computed on a 3D domain of the water volume. So we have this generic scheme, and the 3D model of the water volume is built with tetrahedral cells. So this is from the point of view of the development of the adaptive scheme for sampling. And then there are also the carrier for validation. And we have on the French side, in EMRA2021, the Vortex EUV, and on the Italian side, in CNR, the Proteus EUV. And we have two different procedures, because in French, in the Toulon Harbor, EMRA2021 can work with the vehicle in EUV mode. So it is connected to the surface station through acoustic-based underwater localization and communication system. On our side, in Genova, we discussed with the port authorities and so on, and it is possible to operate the vehicle only physically connected to the support vessel. So the idea related to that, we also thought, okay, let's try, because in the harbor, the depth, maximum operating depth is not so high, if we can develop something cheaper for knowing the position of the vehicle and communicating with it without using an acoustic underwater communication and positioning systems. And so the idea was to develop a kind of surface buoy for communication and localization with an active winch for keeping it directly on the top of the EUV. Of course, all the sensors have to be collected on board the vehicle and with the same timestamp and so on. So on the French side, EMRA2021 is developing a multi-sensor hub, and in CNR, we are also developing a dedicated the acquisition system for the sensors. And I'm sorry, I have to go back. Okay, so this is a view of the scheme of the navigation and communication system and payload system that we are developing for Proteus EUV. So on the surface, we have a kind of navigation and communication system with a GPS and radio communication antenna, and it is completely managed by a computer system based on Raspberry, and we have an automatic winch that, on the basis of the vehicle depth that is communicated through the cable, can manage the length of the tether at sea. Of course, there is a special dedicated module that will be mounted on the vehicle with all the MATRAC sensors. Here in this slide, you can see a short movie showing last week preliminary test of the system with this surface buoy. We were in the Genova harbor, and we had, of course, a delay due to pandemic. With last year, the activities completely stopped, at least for experimental activities, and we plan to have a final demo during next September. And what to say about them? This is a European project, and what is important from EC project is the capitalization of results of projects. And now I am talking about MATRAC, and before Matteo presented the INNOVAMARE, tomorrow we will have a presentation of 2 other projects that are Blue Roses and Milestone. Basically, the results that we achieve in MATRAC about the technology for collecting data for monitoring of waters in harbors will be exploited in an EMFF project, Blue Roses, for monitoring the quality of the waters in the Viareggio harbor. And then all these results are being exploited also in the INNOVAMARE project, where 2 surface vehicles with some equipment like that will be developed. And they will be in Venice. And these vehicles will be exploited in the Milestone project for monitoring and collection of plastic waste in Venice lagoon and channels that my colleague Valentina Matricardo will present tomorrow. And this work needs a huge team, interdisciplinary and transborder team. And the partners are the National Research Council with the Institute of Marine Engineering and the Institute of Applied Mathematics and Information Technology, the University of Genova with the Department of Earth, Environment and Life Sciences, and EMRA2021 in Toulon. And we have here mentioned all the people who worked in the project from the technical and scientific point of view, and also for this kind of projects Interreg, there is a huge work also for our colleagues administrative, and I thank all of them in all 3 institutions involved. And okay, so the presentation is ended, and Pisa is inside the Interreg Maritime Italy-France region, and so Toulon was. So with MATRAC, we had the opportunity of funding last and this edition of EMRA. And I would like to invite all of you to the MATRAC-ACP aperitivo that will be held online at the end of this session. So thank you very much for your attention, and see you in just half an hour or something like that.
Thank you, Massimo, for very interesting presentation. But before that aperitivo, we still have one more talk, and next talk will be given by Miguel Ribeiro from USA, and it will be about strategic robotic systems, the research underlying the fusion system.
Hello, can you all hear me?
Yeah, we can hear you.
Okay, let me start the share screen. Massimo, I think that you had to stop sharing your screen before I...
Okay, no. Stop, okay. Sorry.
That's all right. Okay.
Okay, everything is fine. Yeah.
Okay. Let me do this. Okay. So I'm Miguel Ribeiro. I will be presenting Fusion, the hybrid underwater vehicle. To give you a little bit of a background, the initial system design and implementation started in collaboration with the group of Professor António Pascoal in IST, Portugal, a group that I was part of, and with which SRS still has an ongoing collaboration. I'm seeing here plenty of familiar faces, people that I had the pleasure to work with in IST in several EU-funded projects. For those, a special greeting. So Fusion was initially designed to be very intuitive and have streamlined operation. in previous generations of ROVs, and there was a very steep learning curve with the low level of autonomy that the robots had. And with Fusion, leveraging that autonomy makes the data acquisition quicker and easier and more efficient. Also, another change that Fusion has brought to the table was to be able to be man-portable and not requiring a generator at the surface. And lastly, also to reduce the learning curve because of our typical operators being divers or people that are not familiar with underwater equipment. So I was mentioning that Fusion is a hybrid underwater vehicle because there are 3 modes of operation. One of them, the ROV, where we can see all the data that is being recorded through the tether. AUV, where you pre-program a mission and then let Fusion go, acquire the data, transmit very few amounts of data through the acoustics, but mainly you would review the data after you recover. And also the diver module that is under development, where the diver would leverage the sensors and the navigation capabilities of the system, and also the propulsion. So the basic system components of Fusion are the vehicle itself, the tablet here in the middle, and the tether. As you can see, Fusion has 7 thrusters with which we can control the 6 degrees of freedom. On the top, there's a GNSS, acoustic modem, and attitude and heading reference system. And in the front, built into Fusion is a forward-looking sonar. This is a imaging multibeam, some lights, camera with tilt, some aux ports, and then on the bottom you can see the DVL transducers and payload bay, where you can append a payload, Picatinny rails to mount other sensors, and a small screen on the rear to see some system diagnostics. As part of this intuitive and streamlined operation, the batteries are hot swappable, and also we can swap thrusters with no tools required. Not that it has been a problem, because very rarely we need to do it. Regarding another part of the system, the tether, it is a fiber optic gyro with reinforced with Kevlar on the outside, and the maximum length that you can have is 2 kilometers, and allows us to access all the sensors with gigabit connection. The last standard part of the system is the tablet, that is a rugged one with the HMI, so case around it with joysticks and some buttons to interact with the system. It has USB, LAN ports, and docking station to connect things that are not standard, and also a GNSS, such that you know where the tablet is with respect to the vehicle. So here's a glimpse of our user interface in ROV mode. On the top, you can see some navigation data, but the main focus of a robot like this is to acquire data. So you can see in the bigger part of the screen, the video, the navigation, and the forward-looking sonar. There's also the side scan that is not depicted here, but it's pretty easy to swap between these. So if one goes to the bottom left or right corner and clicks that, it will switch the view and show it in the main square. So some examples of data that what I was saying, and data that we acquired. On the left, you can see a 1927, I think, Chevy that was close to our headquarters when we were looking for something else. We were lucky to find this. And on the right, our forward-looking sonar in the same UI, we running in the high frequency mode because it's a dual frequency one. There's also the side scan, and we can see it in waterfall display as on the left, where it is time dependent, and on the right you can see us doing a real-time mosaic overlaid on top of the map. So having satellite images that are loaded from the internet, and then we would generate these mosaics online. As for modes of operation, there are 3 of them. The first one being the joystick operated, that we try our users not to use. It's only has a if they really require, because as data acquisition is very important, going to a higher level of autonomy and leveraging the sensors like DVL and etc. We can provide more autonomy than that. The second mode of operation is control mode, where you can see on the right of the screen this virtual touchpad where the user gives position shifts for all the axes, and then in mission mode that you can program a mission and the vehicle will run it autonomously. You can see here in the mission that you can configure which sensors you want to have turned on or off. If it is something that you only want to acquire side scan sonar, for example, and that the video will not be of much use, you can turn it off to save battery and space on the hard drives. Being this hybrid system, it is very important to have a unified interface. That's what we have. So here you can see the replay screen that is very similar to the ROV screen, for example, where you can see the different types of data, and in the bottom middle, you can see the profile. In red is the depth, and in blue the altitude. And so you can scroll as it was a medial player and have all the data synchronized among the replay. And on the top, of course, the navigation data that was pretty similar to what it is in real time. As for optional items that the clients can have, here on the top left corner, a magnetometer, and I've shown some pictures also of the grabbers. Here there's a dual file function that are controlled with 3D space mice. There are also some dual function that only rotate the wrist and open and close. And the top side navigation pod, the USBL unit that you can see in red, the aux screen to have a second operator over looking at the data at the same time as you without having to look at the primary screen, and payload bay, and etc. So although our the main part of our users are end users that are Navy or Coast Guards that are operators, we are also developing an API for research. So with this is a way of something that we call the backseat driver. So to allow everyone to run their own software inside our vehicle or outside. This is ROS enabled. So with all that comes with ROS that can be used at the same time. And with these, users can leverage the controllers that are already in place, communication stack, or etc., or override them and use them as per their project requirements. I'll then show some pictures of first ship hull inspections. Here on the left, some anodes of the boat, and in the bottom right, something that our US Navy clients are very interested with. The IED stands for an improvised explosive device. And something that is close to our headquarters, there is a plane that is a Second World War bomber that's had an accident just before taking off. And because it's fresh water and cold, it's after 60, 70 years, it is still intact. You can go there and see the guns, see the cabin, and etc. So it's pretty remarkable. Okay, this was my presentation. Thank you for your attention, and I'm available if there are any questions.
Thank you, Miguel, for really very, very exciting presentation. So now I would like to invite all four speakers from the last session to switch camera on and microphones, and we will try to answer some questions from people who are listening to this session. So I can see now, for example, the first question from Salvatore, and he asked, the question is for Mateo. Do you plan to monitorize or measure also the URN? Mateo, are you there? Okay, I think we don't have Mateo now online, but anyway, we will switch now to the next question that is available in the chat. So we have a question for Jorge. Do you plan to take in account or optimize the hydrodynamic characteristics of your bio-inspired swarms in order to fulfill energy efficiency targets, if any?
Yes, I think, yeah. Yes. Yeah, we are using some sensors. This is a work from Tallinn. They are using some sensors along the surface of the robot, and this is the way they do it. Okay, so and basically it's what I know about this specific question. I think some of the information that you are looking for is also in the paper. I left already the PowerPoints on the system. Maybe you can just pick up these four publications are available there. Okay, I think Giuseppe is the best way to do is this way. Okay, looking for that information.
Thanks. And okay, I just want to clarify that first question was from Salvatore Mauro from CNR-INM, but I have another question for Jorge, for Giuseppe Casalino, for estimating the velocity of AUV with respect to the water. Were you using a set of disturbed fluximeter or what?
Yeah, yes. This is a very important question, Salvatore. Yes, we would like, to take into consideration using the observation, but not just that, yeah. The energy is the energy by two sides. One, from the way you just do the locomotion, but also the way you just use your data and your previous data. Yes. On all the things that are related, energy for the propulsion and also energy for the computation part. We're trying to blend. The idea is to put this intelligence on the computing part and also distribute it on the body hardware. Yes.
Okay, thank you, Jorge. And now we'll go back to the first questions that was.
Thank you, Jorge.
To Mateo, but as I can see now that Fausto can answer on behalf of Mateo because he's in the same project. So please, Fausto, can you answer the question?
Yes, can you hear me? Yeah. So yes, as part of the project, at least one PhD student that we have here will be working on measuring underwater noise for different applications, either the detection of divers, protection of underwater cultural heritage, so detecting noises of people trying to get to a place that is forbidden, or detection of ships, basically.
Okay, and can you have Fausto please clarify what does it mean, abbreviation URN, just for people maybe.
Underwater radiated noise. At least that's what I expect. That was the question for. If it's something else, then I can't answer.
Okay, thank you. Okay, we move now to the next question for Miguel from Salvatore Mauro from CNR. And do you know the close and far field URN threshold of your fusion product?
Unfortunately, I don't. Sorry for the answer.
Okay. Do you have any estimation or something or no?
I don't think that we have ever measured it, but I can check, and feel free to email me and I'll get back to you on it.
Okay, and thanks, Miguel. I would like to ask you one question for your configuration of the thrusters.
Yep.
How reliable are your thrusters? How well they work first?
Say that again, sorry, the last part.
How reliable are your thrusters? Do you have any issue that they don't start, they don't work well, or do you have problem with dead zone or something like that?
No, in the beginning we have a few issues like anything when it's starting, but because of the flooded design, we haven't had any issues. The dead zone is neglectable, so yeah, we are pretty happy with our solution currently.
And do you have any estimation of the accuracy of your positioning system after 1-2 hours of operation? How accurate is your positioning?
So because we rely on magnetometer, basically the basic operation is based on dead reckoning with the DVL and compass. The navigation error is about 1% of the distance traveled. But then if you have a USBL at the surface, that error can be reduced, of course.
Okay, thanks. I would like to ask everybody, are there any more questions for our speakers?
Edin, this is Giovanni. I had a small one for Miguel, if possible.
Yeah.
First of all, I would like to say hi. I don't see him since a while. We worked together on a project a few years ago, and it was very nice to. It's very nice to see you again, Miguel. I was wondering regarding this setup. You mentioned the possibility to install a payload below the vehicle. Can you tell us anything more about the interfaces that are available? And also how the amount of payload in terms of weight, how much you can, weight and volume, I mean.
Okay, so regarding the amounts of payloads, there are two RS-32 connections in the front, one of them in the payload area, and 2 Ethernet connections that can be used. And regarding volume, we've tested it up to a maximum of 10 kilos in, I don't want to be misleading, but I believe it was 10 kilos in water.
So pretty large. And can you also provide power to the payload, or does it need to be let's say, self-sufficient with power?
We can provide power. Our nominal voltage is 28 volts.
Okay. Very interesting. Very nice design. Thanks for your
You're welcome.
presentation.
Thank you. And I would like to ask everybody, are there any more questions for our speakers?
Edin, maybe there is also a question coming from Pino Casalino to Jorge in the chat.
Okay, I think I already asked one question, but maybe if there is any new. I cannot see any new.
I think Jorge has already answered to this, I think.
Yes.
Yeah.
I see, thanks.
Yeah.
Thank you.
Okay, sorry.
Thank you, George. Thank you, George.
Yeah, very welcome.
I would have a curiosity for Massimo. If I understood well, you said that you was not able was not able to use the robot not connected to the support vessel in the port area. Can you give us some more information about this, if it was a particular operating condition or?
No, Alessandro, this is basically because of the rules of the law. Because if we discussed it with the society that is in charge of monitoring the waters inside the harbor, and what happens is that if you are connected with a physical connection to the support ship, the vehicle is seen as a tool of the ship. And so there are completely rules. Otherwise, you need to ask for operating and so on. So it is more complex from the point of view of legal aspects. So we made the decision of saying, okay, because we have the opportunity of working in two different ways, in Italy and in France. And the goal of the project is to understand how it is possible to work in these conditions with usual operators, and how can we help them and facilitate their job. So, and also the idea is, for instance, if you have to work in different places, I mean in different piers and so on along a harbor, you cannot have a fixed acoustic-based positioning and communication system, of course. In that case, you should mount it on the support vessel to have a USPL and so on. And it could be not so easy. And we said, okay, let's try to evaluate what happens if we put a less than 20 kilos device in the water that is this kind of buoy, and if we can manage the tether knowing the depth of the vehicle, also because you know, in the harbor we work in 0-12 meters, so not too much, and so maybe it is possible. But I hope that next at the end of September we will be able to provide you feedback about operational what will happen operationally with this new ideas.
Thank you, Massimo.
Yeah.
And I would just like now to ask, are there any more questions now for our speakers?
I see a hand raised by Jane Ramirez.
Okay, I have there is a okay, I think I cannot see any new questions here in chat. So I would like now to close this session, and first big thank to all our speakers in this afternoon session, and also to all speakers today. I think we had a very useful and a very fruitful day today for the first day of the EMRA 2021. But I will now give floor to the Alessandro to introduce the
Alessandro, there is Jane.
Yes, maybe
trying to say something.
Yeah, there is a final question probably.
Sorry, can you hear me?
Sorry, I did not see that on time. Yeah.
Can you hear me?
Yeah, we can hear you.
Good evening from Pisa, Italy. Thank you for all your interesting presentations. I would just like to ask a brief question for Professor Jorge Diaz. What is your outlook on the direction of research regarding bio-inspired design and applications, specifically to blue growth in marine robotics?
Blue, sorry again, can you just repeat?
Sorry, what is your outlook on the direction of research regarding bio-inspired design and applications, specifically to blue growth and marine robotics?
I see, yeah. So we don't have, so we intend to use these robots to be observers from the environment and using them, but we don't, currently we are just using the data acquired by the images. We didn't elaborate more than that. We didn't elaborate things like correlated with salinity in conditions under the water. I think is an avenue that we would like to address on the consortium, but yes, we need people interested on that. If you are one of the cases that are interested, please join, and then we can just start iterating on that. So the platform for ECOBOTICS is a platform for doing innovative research, targeting more science around the environment. So if it's something that you intend to address in the future, yeah, we are quite happy and discuss this. Currently ourselves, we think that is important to do it. We think that someone need to deal it, but you don't have time for many topics that you have in hands.
Thank you so much for your answer. Thank you, Sir Pascual and everyone. Thank you.
Thank you.
Thank you. And I would ask now Alessandro to close the day and to introduce the aperitivo that is coming next.
Thank you very much. Thank you very much, Dino. Yes, so we are at the end of the first day, but there is now a very important social event. So as Massimo anticipated, there is an aperitivo